Okay, this section is going to talk about 6.4, which is the graph of the logarithmic function. So if we go back to exponential functions, our graphs looked kind of like this. I mean, there was multiple shapes, but the domain is negative infinity to infinity, and the range of the parent function was 0 to infinity. In 6.3, we learned that logs are the inverses. So if the exponential looks like the red one, the log's going to look like the blue one, and the x and y switch. So now our domain is 0 to infinity, and our range is negative infinity to infinity, which goes along with the fact that we said we can't have anything below 0 or lower in our argument, but we can get negative answers. Now, one of the properties that is very helpful is the change of base rule. Now, we can give you any base in a problem, but you can only type base 10 in the calculator. So to change it to base 10, you rewrite this as log of the argument over log of the base. And then you can change it into any base, but it's helpful to put it in base 10. So if I rewrote this one, I would do log of the argument over log of the base. And now the base of both of those is 10, but the arguments are different. So if I did this one, it would be log of the argument over log of the base. Now we would be able to type that in the calculator. So change of base is very helpful. So let's talk about graphs of logarithms, okay? If you graph it, you might as well do it on the calculator. That's going to make your life easier. Your domain is based on the argument. Remember, your argument has to be greater than 0. Your range is going to be negative infinity to infinity. And then your vertical asymptote is the line it approaches. So we're going to look at a little bit here. The first thing we're going to do is we're going to rewrite f of x so that we can put it in the calculator. So using change of base, we'll do log of x plus 3 over log of 2. Then we're going to put that in the calculator. So y equals, that's this button up here. Then you're going to type log x plus 3. Make sure you close the parentheses, and then divided by log 2, close the parentheses. Then hit graph. If your graph looks weird because you've done something else with it, looks weird, hit zoom 9, and that's going to automatically snap it to this 10 by 10 grid. So on the calculator, this is my graph. It looks something like this. Okay. The domain is the argument greater than 0. So we're going to take the argument of this log, x plus 3. I should do it in red. X plus 3 is greater than 0. So I'm going to subtract 3 from both sides. So my domain is x is greater than negative 3. The range is negative infinity to infinity. And then the asymptote. What an asymptote is, if you remember from the rational function, is it's a line that it approaches and never crosses. That's going to be the same line as the domain. So if my domain is x is greater than negative 3, my vertical asymptote is x equals negative 3. All right, let's do another one. Okay. Oops. So for this one, we're going to do our change of base. So I'm going to do log of x minus 2 over log of 5. That plus 1 is not in the log, so we're going to leave it separate. Then I'm going to hit my y equals button. That's this top button. That's how you graph. And I'm going to type log of x minus 2 divided by log of 5 n plus 1. And then I'm going to graph that. So if I look at this, there's my graph. To find the domain, we need our argument to be x minus 2 has to be greater than 0. So I'm going to add 2 to both sides. So my domain is x is greater than 2. If I was to put that in interval notation, it would be 2 to infinity. Those are the same thing. The range is negative infinity to infinity. What that means is even though you don't see it on the calculator, this is an arrow and it does go down. And then our vertical asymptote is that line that it gets closer and closer to, which is based on our domain. So the vertical asymptote is x equals 2. All right, let's do one more of these. Okay, so we're going to use our change of base. So we're going to say log of x minus 4 over log of 1/2. We're going to type that in the calculator. Log of x minus 4 divided by log of 1/2. Graph it. This one's decreasing. So just like exponents, you can have increasing and decreasing. But our domain is going to be the same thing. We take the argument, make it greater than 0. Add 4 to both sides. So our domain is x is greater than 4, or 4 to infinity. Our range is still negative infinity to infinity. And our vertical asymptote matches the domain, so it's x equals 4. And that's what you need to know about log graphs. Let me know if you have any questions.